Hi students, good afternoon. Today we are going to discuss about Snell's law. This law shows the relationship between angle of incidence and angle of refraction when any light ray which moves from one transparent medium to another transparent medium. To prove this law, we assume one situation in which one person has fallen from the boat into the water and is screaming for the help. Another person seeing the situation and trying to help. So, this horizontal line is treated as a shore of the any ocean or river where the person fallen from the boat into the water. This is treated as a point B. And another person who is on the shore seeing this situation who is existing at point A. So, when this person travels from point A to point B, which path is taken least time to travel? For example, this path ACB path is the least time taken path. Assume that ACB is the least time taken path. Here you get one doubt. How can you clarify the ACB path is the least time taken to travel from point A to point B? By using mathematical approximations, we can find the ACB path is the least time taken path. How? For example, here one person who has fallen from the boat into the water and screaming for help. Another person at point A trying to help this person. According to general ideology, we know that the velocity of the human beings is more on the earth or land when compared to the water. So that he chooses the path to reach B from point A in such a manner, he travels more distance on the earth, less distance in the water. Like this, for example. Choose that this is a ABB path. According to mathematical approximations, there must be exist one more path in such a manner if we travel through that path less distance on the land, more distance on the water, and also it takes same time when we are traveling through ABB. So choose those paths like this. This path is AP dash B. When this person traveling through either APB or AP dash B, he takes same time when he traveling from point A to point B. Again, he chooses one more path, A, Q, B. To travel from A to B. We have already known that according to the mathematical approximations, there must be exist one more path to take same time when we traveling AQB. So those path is like this. When this person traveling AQB, either AQB or AQ dash B, he takes same time. So we are doing this activity more times, A or B, A or dash B, like this. We get one path. Those path is least time taken path. How can you say that? So by drawing one graph in which we are plotting time on the y-axis, distance on the x-axis, other than we get here P dash, Q dash, R dash, C, R, Q, P. So we assume that the time is same when we are traveling either APB or AP dash B. So that the dots come at this place in the graph. Again, the time same remains same when we are traveling either AQB or AQ-B. The same manner, the time remains the same when we are traveling either AR-B or ARB. So, this is time when we are traveling through ACB path. Join all these points, we get one fine curve. Draw from the bottom of the curve, draw one line which is parallel to the x-axis from the bottom of the curve and one line parallel to the y-axis. Then we get the least time taken path. From this graph it is very clear that ACP path is the least time taken path to travel from point A to point B. Okay? So that's why we concluded that any person who travels from point A to point B through ACB, this path is the least time taken. Okay? Again, according to mathematical approximations, there must exist one more path. If we travel through that path, it takes same time while traveling ACB. So those paths is A, D, B. So this is one medium. The refractive index of this is nothing but A. So the refractive index of this transparent medium is N1. This is nothing but water. So the refractive index of the water is treated as a N2. So any human being who travels more fast on the earth compared to the water, so the velocity of the person on the earth is V1. Velocity of the person in the water is V2. Okay? So here we get two incident points on the interface. So this is treated as a shore or interface of the two transparent media. Draw one normal at C. This is incident ray, this is treated as an incident ray, this is treated as a refracted ray. So here two angles are formed. One angle is the angle between incident ray and refracted ray. Those angle is incidence angle. Here the angle between normal and refracted ray, this angle is called refracted angle. Again one normal at point B. Here also we get two angles. We have already assumed that when we are traveling through the ADB path, it takes the same time when we are traveling through ACB. So that here also the angle of incidence is I. Here also the angle of refraction is R. Okay. Now we draw one perpendicular from point D to first incidence ray. So this point is treated as a F. Again, we draw one perpendicular from point C to second path, that is called treated as a F. This is treated as a E. Okay. So this is perpendicular so that it is 90 degrees. It is perpendicular so that it is 90 degrees. So by observing this diagram, it is very clear that when any person who travels through the ACB path, he travels more distance on the land is easy. At the same time, any person who travels through the ADB path to reach point B from A, he travels more distance df in the water. But while traveling through these two paths, the time remains constant or the time remains same, so that the time taken to travel EC distance on the earth is equals to the time taken to travel df distance in the water. So according to the formula from time, distance and speed, time by speed. So EC by speed. Traveling on the speed of the person is V1. While traveling in the water, the speed of the person is V2. Okay? By getting cross multiplication, EC by df is equals to V1 by V2. So this is treated as an equation 1. So again you observe this diagram. We draw two normals from point D to DE normal and CF normal. Here two triangles are formed. Draw those triangles separately. So this is D, F, C. This is normal. Here this angle is I. From this point to this point, the value of angle is 90 degrees. So that it becomes 90 minus I. 90 minus I. So this is the normal from point D to E. So that this is 90 degrees. It is a right angle triangle. At the time, the value of this angle, according to the formula properties of the triangle, the sum of the three interior angles in any triangle is equals to 180 degrees. So that 90 plus 90 minus I plus angle D is equals to 180. So that this becomes I. Here DEC is a one right angle triangle. According to properties of the right angle triangle, the side which is opposite to right angle is called hypotenuse. So DC is the hypotenuse. Again we find the we draw the triangle DCF. DCF. Here also one normal is there. This is R. At the time it must be 90 minus R. Sorry. DC. DCF. So this is 90 degrees. From this point to this point, the value of the angle is 90. This is R. So then this is 90 minus R. Other than the sum of the three interior angles of any triangle is 180. So that this value becomes R. 90 minus R plus 90 plus angle C is equals to 180. By solving those equations, we get this angle C is equals to R. Okay, from these two angles, we can find here also, this is also DFC also, one right angle triangle. The side DC, which is exactly opposite to the right angle, so it is called hypotenuse. By using these two right angle triangles, we can find the trigonometric ratios. By using first triangle, we can find from DEC triangle sin I is equals to opposite side by hypotenuse. Here this is the angle. Which side is opposite to this angle? EC. So opposite by opposite side by hypotenuse. So that sin I is equals to EC by DC. Again, from one more triangle is there, DCF triangle. Here also we have to find the sin R ratio. Sin R opposite DF divided by hypotenuse DC. Okay. So write the ratio between sin I and sin R. EC by DC whole divided by DF by DC. Then EC by DC into DC by DF. DC gets cancelled. So sin I by sin R is equals to EC by DF. Treat it as the equation 2. By observing equation 1 and 2, in both equations we get the value of EC by DF ratio. So EC by DF is equals to V1 by V2. Here also EC by DF is equals to sin I by sin R. So that we can equate sin I by sin R is equals to V1 by V2. V1 by V2. According to the relative refractive index definition, V1 by V2 can be written as a N2 by N1. N2 by N1. N2 by N1 is equals to V1 by V2. N2 by N1 means N2 1. The refractive index of the second transparent medium with respect to first transparent medium is called N21. It can be written as the velocity of the light in the first transparent medium to the velocity of the light in the second transparent medium, V1 by V2. So in the place of V1 by V2, we can write sin I by sin R is equals to N2 by N1. By getting cross multiplication again, N1 into sin I is equals to N2 into sin R. So this is the Snell's law. By using this law, we can Observe the relationship between angle of incidence and angle of refraction when any light ray which travels from one transparent medium to another transparent medium. Any light ray at any incidence, the refraction is occurred. When the refraction is occurred, those light ray travels from one transparent medium to another transparent medium. At the time refraction is occurred, at the time those light ray must possess the Snell's law. N1 into sin I is equals to N2 into sin R. Now we are going to discuss about critical angle. For this here we have one situation. This colored part is treated as a denser medium. This is treated as a rarer medium. This is denser, this is rarer. The refractive index of the denser medium is N1 and rarer medium is N2. So choose any one point on the interface. Any light ray which travels from denser medium to rarer medium. We have already known that any light ray which travels from denser medium to rarer medium, the corresponding refracted ray moves away to the north. But in this situation, any light ray which travels from denser medium to rarer medium at particular angle of incidence, the corresponding refracted ray grazes through the interface of two media. Thus particular angle of incidence is called critical angle of this denser medium, what we have taken in this particular context. So any light ray which travels from denser to rarer at particular angle of incidence, the corresponding refracted ray grazes through the interface of two media. In other words, the angle of refraction is right angle. The angle of refraction is 90 degrees. Then those incidence angle is called critical angle of those denser medium. At the time those light ray travels from denser to rarer. When the light ray travels from denser to rarer, the refracted angle is 90 degrees. Then we can say that those particular angle of incidence is called critical angle. So here the angle between normal and incident ray is called incidence angle. So here refracted ray grazes through the interface of two media. So this angle is called the refraction angle. This angle, the value of this angle is 90 degrees. So refractive index of a first medium N1, refractive index of a second medium N2. We apply Snell's law here. We get N1 into sin I is equals to N2 into sin I. Okay, so N1 into sin I is equals to N2 into sin R. How much here? 90 degrees. So N1 into sin I is equals to N2 into sin 90 is equals to 1. Here this particular angle of incidence is treated as a critical angle, so that it is write as C, sin C is equals to N2. So sin C is equals to, by getting cross multiplication, N2 by N1. It can be write as N21. So sin C is equals to N21. N21 means relative refractive index of a second medium with respect to the first medium. It can be also write as sin C is equals to 1 by N1 to 1 by N1 to 1 by N1 to. So sin C is equals to 1 by N12. So this is the algebraic expression for critical angle. Sin C is equals to 1 by N12. So here also one phenomena is there. If any light ray which travels from denser to rarer with more than critical angle value, other than the corresponding refracted ray reflects into the denser medium, reverses into the same denser medium. This phenomena is called total internal reflection. Total internal reflection. So here, when it is also one property of the light. Here one particular condition is there, that is the light ray which travels from denser to rarer. The light ray which travels from denser to rarer. If any light ray which travels from denser to rarer, which must be having more than critical angle of incidence, at the time the corresponding refracted ray bounces back into the same denser medium. It reflects. Here refraction is not occurred, reflection is occurred, so that this property is called total internal reflection. Total internal reflection. Again, any light ray which moves from denser to rarer medium more than value of critical angle of the denser medium, the corresponding refracted ray reflects into the same denser medium. This phenomena is known as total internal reflection. Now we are going to discuss about applications of total internal reflection. So by using this phenomena, there are so many things which are occurred in our nature, and we are observing so many things, but we can't know those things happen due to total internal reflection. First, mirages. Mirages are formed due to total internal reflection. First of all, what is meant by mirages? So, mirages is an optical illusion. When we are traveling on the roads, at the time some water deposits are formed at distant distances, but when we go there is no water deposits. This optical illusion is known as mirages. So, mirages is an optical illusion. When we are traveling on the roads, in hot summer days, when we are traveling on the roads, water deposits are appeared at distant distances, but there is no water deposits when we go there. This illusion is called mirages. How the mirages are formed? So mirages are formed by using the phenomena of total internal reflection. Here some explanation is there. For example, this is treated as a road. One person stands here. Here some water deposits are formed. Just now we defined that mirages are optical illusion. While we are traveling on the roads, water deposits are formed, or water deposits are appeared at distant distances, but when we go there is no water deposits. How these water deposits appear at distant distances? Here total internal reflection is occurred. Here only one medium is there, only, that is air. This is also transparent medium, but here one medium acting as a, at the same time one medium is acting as a rarer medium and a denser medium. How is it possible? Due to temperature of the environment. Here, for example, the air which is nearer to the road surface is very hot. The air which is far from road surface, or the air which is at higher altitudes, has less temperatures. So the air which is at higher altitudes has less temperature means the density of those air is high. The density of those air is high. The air which is nearer to the road surface has high temperature, so the density of those air is low. So the hot air which is nearer to the road surface is treated as a rarer medium. The cool air which is at higher altitudes from the road surface is treated as a denser medium. So some light rays which comes from higher altitudes. So here at any place we assume an interface. Interface means the surface which divides rarer and denser. So the light rays which come from higher altitudes incident at different points of the interface. Some of the light rays having the value of their incidence is more than the critical angle of this particular denser medium. More than this particular denser medium. Those light rays gets internal reflection. Those light rays, those internal reflected light rays reaches to the eye of human being who travels on the road. At the time he can see the water deposits on the roads at distant distances. So here the mirages are optical illusions. Those water deposits appear to the persons who are traveling on the roads because of total internal reflected rays reaches to those persons' eye. Here only one medium is existing. Here air, but the cool air is acting as a denser medium. The hot air which is nearer to the road surface is acting as a rarer medium. So due to the temperature variation, the air is acting as a denser and rarer. So this is the formation of mirages. Second one, optical fibers. Optical fibers also working on the principle of total internal reflection. Optical fiber is a very thin fiber. It has the radius about nearly 1 micrometer, means 10 power minus 6 meters or 1 by 10 power 6 meters. It is called 1 micrometer. Optical fiber is a very thin fiber which is made from either plastic or glass. It has nearly 1 micrometer radius. The bunch of these optical fibers placed in one glass pipe, in which some optical fibers transmits light energy and some bunch of optical fibers collecting those light energy from inside of the any substance to outside. Where these optical fibers are used? Generally, whenever we get any disturbance in our internal organs such as intestines, at the time we go to doctor makes some test. For example, endoscopy, in which optical fibers are used. Is there any damage on the layers of intestines occurred? At the time, optical fiber, one glass pipe by using one tube placed, inserted to our stomach through the throat, in which optical fibers are there. Those optical fibers are working on the principle of total internal reflection. So some bunch of optical fibers, the light energy transmits from outside tube inside of the stomach. The image of the inside of the stomach or inside of the intestines appeared very clearly, those images again recollected from another bunch of optical fiber which are also placed in the glass pipe, and those internal reflected light rays again come back from the stomach to outside. Those bunch of optical fibers connected to any computer or any out device. Those images formed on the monitor, and the doctor observed very clearly, and he give advice for medicine. So here optical fibers are working on the principle of total internal reflection. Next, third one, diamonds. It is one form of carbon. It glitters and it shines more than any other substance on the planet, on this earth. Why the diamond glitters more? Why the diamond shines more? Because the refractive index of a diamond is nearly 2.42, I think, and the critical angle of the diamond is very less, that is nearly 24.2 degrees. When any light ray enters into the diamond, those light ray gets more multiple internal reflections, so that those diamond glitters more or shines more. That's why the diamond shines more. Diamond shines more or the diamond glitters more due to the total internal reflection, because the diamond has less critical angle value 24.2 degrees, and the refractive index of the diamond is also 2.42. Okay. Next, last case. It is also one of the application. Optical fibers. Nowadays, optical fibers which are used to transmit the telephone signals, internal signals from one place to another place very efficiently when compared to the conventional methods. So nowadays we are using cell phones, we are using computers, we are making video calls, and we are watching so many sports and events which are occurring around the world very easily and very clearly. By using cell phone, we can see any things which are happening around our surroundings and other countries also. So here, how those communication signals transmitted from one place to another place. All those transmitted signals transferred from one place to another place by using optical fibers. Olden days we are using telephone signals and telephone waves are transferred from one place to another place by using metallic wires. Nowadays those conventional methods are not used. Only by using optical fibers we can transmit telephone communications, net communications from one place to another place very easily. But these optical fibers are working on the principle of total internal reflection. So these are the applications of the total internal reflections. Mirages are formed by using the phenomena of total internal reflections. Optical fibers which are used in the medical sciences, in the test of endoscopy or colonoscopy, optical fibers are used, and also diamond glitters more or diamond shines more by using the phenomena of total internal reflections and all the telephone communications. Now, refraction through the glass slab. So first of all, what is meant by glass slab? Glass slab is a transparent medium which is separated or isolated from surrounding medium, and it is formed by two surfaces which are parallel to each other. The shape of the glass slab is like this. This is a glass slab. So here this Glass slab is also transparent medium. How can you say that it is a transparent medium? Because we can see the objects through the glass slab very easily. That's why we can say that it is a transparent medium. It is isolated from surrounding medium, and also it is formed by two plane surfaces which are parallel to each other. So this is a glass slab. So when any light ray passes through the glass slab, refraction is occurred. How the refraction occurred when a light ray transfers through the glass slab? For example, draw the shape of the glass slab by using pencil along its edges. So it is nothing but a rectangle, two lengths and two bits. Name the four vertices of this rectangle. Remove the glass slab from this place and select any one point on the side AB. This is the incident point. Draw one normal to this point. Again, put glass slab on this rectangle in such a manner. All the edges of the glass slab must be coincide with this rectangle. Place 2 or 3 pins on this normal. All are lying at same height. Observe these 3 pins from the other side of the glass slab and place 2 or 3 pins again in such a manner. All those pins lying in the same straight line. Choose those points and remove those pins and join the line through the points where the pins are placed. Remove the glass slab and join these two lines. What we observe here. So any light ray which moves, this is glass slab, both are transparent mediums. This is rarer, this is denser. Any light ray which incident on any one point of the interface of both media perpendicularly, the corresponding refracted ray doesn't get any deviation. So it is proved. Okay. So again, you draw one more line which makes some angle with normal. So measure the angle between normal and this line. Those angle is called angle of incidence. Place 2 or 3 pins on this line. All are having same height. Again, place the glass slab in this place and observe these pins from the other side of the glass slab. And place again 2 or more pins in such a manner. All these pins being in the same straight line. Mark the points of the pins where they placed and draw the line along those points. So here we get one point. From that point we draw one normal. Here also one angle is formed. This angle is called angle of emergence. Angle of emergence. Emerging. Here the angle of incident must be equal to angle of emerging. If you extend this line and previous incident line, both lines are being parallel to each other. Here some distance is existing between these two lines. Those distance is called lateral shift of the glass slab. Lateral shift of the glass slab. So, by using glass slab, we can measure the lateral shift and also vertical shift. So, here we are doing a small activity by using this glass slab. We require some material such as protractor, scale, pencil, glass slab and one drawing sheet. So, we can do this activity. So, by using this glass slab, we can find the lateral shift. First, we place the glass. We take one white drawing sheet, and we place one glass slab at the center of the white drawing sheet, and draw the shape of the glass slab along its edges. So, name the all vertices. A as A, B, C, D. Select any one point on the side A. By using protractor, we can draw one perpendicular. So the center of point of the protractor must be coincides with the point which is chosen on the side AB, and the base line of the protractor must be coincides with the line AB. You put like this and mark the 90 degrees point. By using scale, draw, join these 2 points. This is the perpendicular to this point. Okay. Again, draw one more line which makes 30 degrees angle. 10, 20, 30. 30 degrees angle. Join these 2 points. This is treated as a incident ray. This angle is the angle of incidence, 30 degrees. This is normal. And place or stick 2 or more pins on this incident line in such a manner all are lying all are being at same height. Okay, again place the glass slab on the rectangle in such a way all the edges of the glass slab must be coincides with the sides of four sides of the rectangle. Observe these pins. Observe the images of these pins from the other side of the glass slab. Okay. Observe the images of these three pins which are placed on the incident line from the other side of the glass slab, and stick two or more pins in such a way all pins are being in the same straight line. So choose those points, remove the glass slab from the rectangle and choose those points and draw the line through those points. And from that point of contact, draw one normal by using protractor. And measure the angle of emerging. Ten, 20, 30, 35. Okay, due to some error it gets higher value, but it must be 30 degrees. Due to some limitations and due to some error we get more value. And extend these two lines. These two lines are parallel to each other. The distance between these two lines is called lateral shift of the glass slab. Here we get emerging angle is more than 5 degrees when compared to the incident angle due to some limitations. It means we have done some error in this activity. So the emerging angle must be equals to the angle of incidence. Okay, this is the lateral shift of the glass slab. Now we are going to do one more activity, that is vertical shift of the glass slab. In this activity we are going to obtain vertical shift of the glass slab. Here we are placing glass slab in the vertical manner and draw the shape of the glass slab along its edges when we place in the vertical manner. Okay, so we get one rectangle. Name the vertices A, B, C, D. Choose one point on the EAB. By using protractor, draw a normal from that point. Join these 2 points, we get one normal from that point we choose on the side AB. Extend as much as possible. and from this point on the side AB we take length AF 15 meters or more than 15 meters. 15 meters or more than, here we are taking 15 meters length. Draw one normal to this point also. Again we put this glass slab in the vertical manner and take one pin and which is placed this point is treated as a P, this point is treated as a Q. We take one pin and place the pin at point Q, which is parallel to the side AB, which is parallel to the side AB. Observe those pin through the glass slab and place one more pin, which must be coincides with the previous pin. Here one point is there. Observe this pin through the glass slab and we place the one more pin by observing from the outside of the glass slab. If you observe this pin from the outside of the glass slab, it is very important to note. You place this pin by observing this pin through the glass slab. You place this pin from the outside of the glass slab. Both are coincide with each other. Both are seems to be coincide with each other. Okay. And mark the point where the second pin is placed and draw the normal to the line of 15 centimeters. Where it contacts this line, those point is treated as a R. Measure the distance between these 2 points. It is nearly 1 centimeter. 1 centimeter. This is the lateral shift of the vertical shift of the glass slab. So here we got 1 centimeter vertical shift and find the thickness of the glass slab by using scale. How much we get? It is nearly 1.5 centimeters thickness. Thickness is 1.5 centimeters. Lateral shift is 1 centimeter. By using these two values, we can find the refractive index of the glass slab by using the formula. Refractive index of the glass slab is equals to thickness of the glass slab divided by thickness
of the glass slab minus vertical shift of the glass slab. So once again, by using these two values, we can find very easily refractive index of the glass slab. Refractive index of the glass slab by using this formula. Here in the numerator, thickness of the glass slab value is placed. In the denominator, the vertical shift is subtracted from the thickness of the glass slab. Here we know two values, so that thickness of the glass slab is how much? 1.5 centimeters, and again 1.5 minus 1, we got nearly 1 centimeter is the vertical shift. That is equals to 1.5 divided by 0.5. So to remove this decimal point, multiplying both numerator and denominator with 10, we get 15 by 5. So 5 1 ja, 5 3 ja. So here refractive index of the glass slab is 3. Refractive index of the glass slab is 3. So to get the, if we get the value of vertical shift, we can find the refractive index of the glass slab is very easy. Okay, so this is the refractive index of by using the lateral shift, by using the vertical shift of the glass slab, we can find refractive index of the glass slab. Okay.